Alright, so this is how to do practice 8 in our acceleration packets. We're starting at rest, so that means our initial velocity is going to be 0 meters per second. When it says it gains 2 meters per second, that means for every second, the speed increases by 2 meters per second. And then right here, 6 seconds is going to be our delta time. Alright, so for box A, we're going to fill this out. Alright, and our velocity is 0 meters per second. And from here to here, in our problem, it said that it's going to gain 2. So we have 2 meters per second. And then we just keep adding. So now that we have our table finished, we're going to go back up to the problem and look at B. Okay, we're going to look at what B is saying, and it starts at rest, so 0 meters per second. Gains 4 meters per second means plus 4 meters per second for every second, and 6 seconds is our delta time. So now we're going to fill out our table based on the information that was given to us. In this situation now we have plus 4 because that's what the problem told us. And well, this one had 2. And now that our table is done, we are ready to make our graph. Let me choose a color. I'll choose orange. I'll choose pink. Okay. We're going to label it. We have 0, 1, 2, 3, 4, 5, and 6. And the most that we have to get up to is 24, so I'm just going to go ahead and put 24 up here. And 24 divided by 3 is 8. So we have 8 and then 16. So for graph A, we start at 0 seconds, 0 meters per second. At 1 second, it becomes 2, then 4, then 6, then 8. So at 4 seconds, it's at 8 seconds. And then 5 seconds, it's at 10. 6 seconds, it's at 12. So I'll just say maybe it's about here. Okay, and I'm going to make a straight line there. For B, it started at 0, 0. And at 6 seconds, I'm at 24. So now I'm here. All right, to calculate the displacement, we have to calculate the area underneath the graph. All right, so we're calculating this area. To calculate this, we use the area, which is, it's a triangle. So a triangle is going to be the base, which is 6 seconds times the height. All right, and so I'm going to do the work maybe in this area. So we have the displacement for A is going to be 1/2 velocity times t, because triangle. Okay, remember that. And then we have 1/2. The change in velocity is 12 meters per second. Okay, and the time is 6 seconds. So we have 12 times 6, which is 72, times 2, which is, or times 1/2, excuse me, which is, I believe, 36 meters. And then we're going to do the same calculation for B. So we have 1/2 VT, remember, triangle, and we have 1/2. So when I do the math for all this, it's going to come out to 72 meters. So this is displacement. This is the position. I'm going to go back and fill this part out. So to fill out the position for A, I'm going to use a displacement, which is we started at 0 seconds, and 0 meters. And we will always start at 0 unless the problem tells us that we're not. So 0 meters. And we calculate the displacement to be 36 meters. Now to get the numbers in between is optional, but we're going to do that work anyway. All right, so for the position at time 1, it's going to be 1/2 our velocity of 2 meters per second times 1 second. And that's going to be 2 times 1 is 2 times 1/2 is going to be 1. So from 0 to 1 second, it went 1 meter. Okay, so we're calculating this triangle right here. Now for 2 seconds, we're going to calculate from here from 0 to 2. And so now we're calculating this triangle. So for 2 seconds, we have 1/2, and we have 4 meters per second right here, times 2 seconds, which is going to give us 4 meters. So at 2 seconds, it has changed 4 meters in position. And if this wasn't 0, we would add this number to whatever the displacement value is, okay? And so then I'm going to go ahead and work out for the other times. All right, so I worked out from time 1 to time 5. And so at 3 seconds, it had reached 9 meters, 16 meters for 4 seconds, and then for 5 seconds, it's 25 meters. And then I'm going to go ahead and do the same thing for B, using B's values. Okay, and for time 3, we have 1/2 times 12 meters per second times 3 seconds, which is going to give us 18 meters. I'm going to go ahead and finish up the rest of this. All right, and so I went ahead and finished writing them out. I'm going to fill out my position timetable from here. I'll go ahead and finish filling the table out, and I'll come back on. So now that I finished the position timetable, I'm going to go ahead and fill out my position time graph. The largest number I have to do for time is 6, so I'm just going to label this up to 6. And the largest value I have to do for position is 72 meters. I'm going to put 72 up here to remind me. And there's 1, 2, 3, 4, 5, 6 lines. 72 divided by 6 is 12, so I'm just going to go by 12. It's not the best number to go by, but it lines up perfectly, and so that's just how I want to do it. You can do it a different way if you want. So let's graph A first. At 0, it's at 0. At 1, it's at 1. At 2, it's at 4. At 3, it's at 9. At 4, it's at 16. At 5, it's at 25. And at 6, it's at 36. So it's going to make this kind of a shape. And from previous classes, we know that it's a quadratic shape. So then to graph B, so that's A, that's A. To graph B, we're going to do 0 meters per second, 2 meters per second, 8 meters, 18 meters is probably going to be around here, or maybe here. And then 32's a little bit higher. And then we have 50, and we have 72. Right, and so this graph is going to connect like this. Okay, this is kind of hard to do on the tablet. So that's how to do the position time and velocity time graphs. And to complete the proportional reasoning, right, the acceleration is given to us. They told us that it increased by 2 meters per second. It was given to us. So 2 meters per second for every second. And the change in velocity is going to go from here, from the initial to the final. How much was that? At 12 minus 0 is going to be 12 meters per second, and the time is 6 seconds. Okay, and so then the problem is asking, what is its speed after 6 seconds? So it wants to know what this is. We're going to go and write that the new one, it's 4 meters per second at times 6. All right, and to get from here to here, we multiply by 2. To get from here to here, we multiply by 1. And so we know that our acceleration is 2, our time is 1. Something over 1 is equal to 2 is going to be 2. And since this is what the problem was asking, I'm filling it out as that. And our new value is going to be 24 meters per second. And this matches this, so it's great.